Hello everyone! Now we're going to look at a circle problem together. A circle centered at O with diameter AB. Angle ABC is 60 degrees. The length of AB is 18 centimeters. They've asked us to find the length of BC. Alright, so guys, let's do it like this. If we also connect AC, you'll form an inscribed angle. See, this inscribed angle you see here, it intercepts the diameter. An inscribed angle that intercepts the diameter is 90 degrees. Alright, great. Now look, 60 is here, 90 is here. So the angle here will be 30. What special triangle do we have? We have a 30, 60, 90 special triangle, guys. Now, didn't they give me the length of A as 18 centimeters? Great, so the side opposite the 90. Let me write it like this. Look, the side opposite 30 is A. Then the side opposite 60 will be a times square root of 3. The side opposite 90 will be 2A. Alright? Now, since the side opposite 90 is already 18, they're asking for the side opposite 30. Isn't that what they're asking from me? This part corresponds to 30, so guys, it will be half. That's 9 centimeters. Hello guys! Now, we're going to look at a length problem in a circle. Let's start together and see. They've shown all the information on the question itself. They're asking us for the length of x. Now, if OA is 9 units, then OC will also be 9 units. Now, pay attention. OE is a radius, guys. OB is also a radius. Now, if you connect O and D, that will also be a radius. Look, a right triangle appears here. There's a special triangle here. If you want, you can also use the Pythagorean theorem, but here we have the special 3, 4, 5 triangle. Look, it's going to be a multiple of 3, a multiple of 4, and a multiple of 5, 9, 12, and this side will be 15. What did we say? OD was also a radius. OB was also a radius. So if this side is 15 units, then this side will also be 15 units, guys. If 9 is here, how much is left for x? 6 will be left. They asked us for the length of x. It will be 6 centimeters. Hi guys. Now we're going to look at a circle question. Let's start together and see. They've shown all the information on the question itself. They also asked us for the degree of x. Okay, now, first of all, the entire circle is 360 degrees. Friends, here, BC is the diameter for us. The arc that the diameter subtends is the BC arc. Let me mark it here for you like this. Look, this is the BC arc, friends. Since this is a diameter, it's 180 degrees. Are we clear? I'm talking about the whole of this part. Now, angle here is A. It's an inscribed angle, and angle A, friends, sees the arc AB. I want you to pay attention here. Alright? The measure of an inscribed angle is half the measure of the arc it intercepts. Or, whatever the measure of the inscribed angle is, the arc it sees will be twice that measure. So if it's 70, then this arc will be 140 degrees. Now, I just said that BC is the diameter, so the whole thing is 180 degrees. If 140 is here, how many degrees are left for the arc AB over there? Guys? There will be 40 degrees left. Now, pay attention. Which angle does this AB arc subtend? It subtends angle D, right? This is also an inscribed angle. What did we say? The measure of an inscribed angle is always half the measure of the arc it intercepts. Or, whatever the measure of the inscribed angle is, the arc will be twice that angle. If this is 40, doesn't that mean the angle will be half of it? Yes. So, how many degrees is this? It's 20 degrees. Super. Now, I want you to focus your attention on this triangle here. They were asking us for x, guys. Let's write x like this. The sum of two interior angles forms an exterior angle independent of itself. So, that will give us x here. Let's add 35 and 20, guys. How many degrees? 75 degrees. That's it. Hello, everyone. Oh, the center of the circle. OAC is a right triangle. AB is 3 centimeters. BC is 12 centimeters. And they also asked us for up. They asked for its length. All right. Now, guys, we have a right triangle, don't we? What if I do this? If I drop another perpendicular from this right angle? Wouldn't that be really nice? Look, we dropped a perpendicular from the right angle. What am I going to use? Of course, I'm going to use Euclid. Now, OK, friends, is the radius. Isn't that right? Then OB is also the radius. So this part is x, and this part is also x. I said I was going to use Euclid, didn't I? Right? Very good. Let's use it then. Look, what is it? X is also the height of this triangle, right? The square of the height, that is, x squared equals 3 times 12, friends. There you go. We solved the Euclid question really quickly, didn't we? X squared equals 3 times 12, which is 36. Guys, take the square root of both sides. Very good. How do we take it out of the square root? 36 comes out as 6. They asked for x. X is 6 centimeters. Guys, we're going to look at another circle question together. The two circles intersect at points E and F. Points A, E, D, and B, F, C are collinear. Angle ADC is 12 degrees. What is the value of x in degrees? That's what they're asking. Okay, now friends, pay attention to the circle here. These are chords, guys. Here, they've formed a cyclic quadrilateral from the chords. In this cyclic quadrilateral, the opposite angles must add up to 180 degrees. So look, if this is 112, then the angle here, guys, will be 68 degrees. If you look at it like this, look, this part here, it forms a straight angle, okay? All right, guys? If this is 68, you'll complete the rest to 180. So this part will be 112 degrees. Now, pay attention to the circle here. Look, here too, there's a cyclic quadrilateral. If the sum of the opposite angles is 180 degrees, and this is 112, then x must be 68 degrees. That's it. Hello, friends. Now we're going to look at a circle question. Let's start together and see. All the information is shown on the question here. They're asking us for the degree of x. Okay, now, first of all, the whole circle is 360 degrees. Here, BC is the diameter for us. The arc that the diameter subtends is the arc BC, guys. Let me mark it like this for you here. Look, this is the arc BC. Since this is the diameter, it's 180 degrees. Are we clear? I'm talking about the whole of this part. Now, the angle here is an inscribed angle. And angle A, friends, sees the arc AB. I want you to pay attention here. Okay? The measure of an inscribed angle is half the measure of the arc it intercepts. Or, whatever the measure of the inscribed angle is, the arc it sees will be twice that measure. So if it's 70, then this arc will be 140 degrees. Now, I just said that BC is a diameter, so it's 180 degrees. If 140 is here, then over there, yes. How many degrees will be left for the arc AB? There will be 40 degrees left. Now, pay attention. Which angle does this arc AB subtend? It subtends angle B, right? This is also an inscribed angle. What did we say? The measure of an inscribed angle is half the measure of the arc it intercepts. Or, whatever the measure of the inscribed angle is, the arc will be twice that measure. If this is 40, doesn't that mean it will be half of that? Yes. So, how many degrees is this? It's 20 degrees. Super. Now, I want you to focus your attention on the triangle here. They were asking us for x, friends. Let's write x like this. The sum of two interior angles makes an exterior angle independent of itself. So, it will give us x here. Let's add 35 and 20, guys. How many degrees? 75 degrees. That's it. Hello, friends. We're going to look at a circle question. Let's start together now and see. AD is equal to the square root of 3 times BC. The CBD angle is 60 degrees. The ACB angle, at how many degrees, is what they're asking us. Now let's start step by step, friends. If AD equals the square root of 3 times BC, if we call BC K, then AD. For us, it will be K times the square root of 3, guys. Let's set it up like this. AD is K. The square root of 3 and BC is K. Great. The angle at CB is 60 degrees. That's what it's talking about here. Let's place it. They've also asked us for the angle ACB. That's exactly what it's referring to here, guys. Now, first, let's do it like this. Look, let's connect DC together with you. All right? Look what happened. DB is the diameter, guys. What is the measure of the inscribed angle that sees the diameter? 90 degrees. Super. Let's put our point here as well. This is 90 degrees. Great. Look, there's a 90. There's a 60, so there will be 30 left here. Isn't this a 30-60-90 special triangle? Super. Now, pay attention. If the side opposite 30 is K, what will the side opposite 60 be? K root 3. That's what it will be. Now, what do you notice? These two parts are equal to each other, right? So, it's an isosceles triangle. If you want, you can call it angle A and use the exterior angle theorem to find the angles. Or it's 30 degrees here, right guys? Right here. Complete this part. It will be 150 to reach 180. So 30 will be left for 180. This part is 15. This will also be 15. That's the angle they were asking for anyway. So our answer will be 105 degrees from 90 plus 15.